To welcome Bobby Bird Jr., also known as Bobby Hart, from LiDAR Drone Services. Bobby is an expert in thermal imaging and drone-based. Hello, everybody. Okay, we're back on stage here with Robert Hart. He's our specialist with the thermal inspections this morning. Robert, how are you doing today?
Not too bad, Chuck. Thanks for having me on. Just real quick. My legal name is Robert Hart, but my father raised me since I was about 9. My mom's always been in my life too, but and his name is Robert. So everybody's always known me as Little Bobby or Bobby Jr. And so that's the Bobby Bird Jr. Thank you for having me on.
I really appreciate you coming. I'm sure you have a lot of knowledge that we all would love to tap a little bit from, and I know I'm been doing a little bit of thermal work myself, nowhere near where you're at, but I'm hopefully on my way. So we can probably bring up a couple of your pictures here and then some of the other ones, and maybe we can talk a little bit about those to get started with. We'll keep an eye out, see if we get any comments, anything coming in from the viewers. Nothing yet. So want to start with one of your pictures you're about?
Yeah, put it on. I'll give you guys a little bit of background. My name is Robert Hart, as we said, and I'm the owner and chief drone operator for LiDAR Drone Services. We're based out of Central Michigan, but we operate all over the country, mainly the Midwest, Chicagoland, Wisconsin, Minnesota, Michigan, Indiana type of deal. And yeah, we specialize in thermal imaging. So LiDAR is actually an acronym which stands for Long Wave Infrared Detection and Anomaly Recognition. And I hold or have 3 separate thermography certifications through FLIR's Infrared Training Center. I have my level 1 electrical and level 1 and level 2 SUAS, which is drone thermography certifications through their course. So I have been actively doing it for over 2 years now. The picture that you have up is actually a building in Chicago that one of my partners had captured the data, and then he sent it up to me and I did the analysis. Excuse me. So what we're looking at is actually just a screenshot of a 3D model that we created. So we'll run oblique missions with the drones to build the model and then go back in and perform our thermal inspection manually and then merge all those images together. So then from the 3D model, those points that are on the model are actually annotations that the client can click on, bring up, and what that will bring up is the manual pictures that we took through the manual flights. We also provide them a color model with corresponding annotations on that as well, and a PDF report. So it's we're trying to combine the new technologies and ways to deliver data to clients while also adhering to what was taught to us within our thermography courses on how to capture data properly. So, it's kind of a balance to kind of do them both.
Very interesting. I learned a lot myself right there. So, all right. Do we want to go to the next picture?
Sure. So this one is actually from a demo capture. I had a DJI Zenmuse H30T. I have one on order now. There have only been demo units in the United States. So this is actually from a demo of it on a new school that our tribe built here in Central Michigan. And since it was a new construction, we were just doing a quick flyover to see the condition as it being new built. So I had brought this image up because the H30T is an entire new level of thermal resolution for drone payloads. This is actually a 1024 by 1280 thermal resolution, which comes out to
Wow.
4 times the resolution that any of our other, like its predecessor, the H20T has. Another thing with this H30T is when we're doing quantitative analysis with a drone, historically we have to take a T-reflect reading, which is essentially we would fly to the altitude that we are going to be performing our inspection at, and then have, say, a 2 foot by 2 foot board on the ground that's tinfoil, crumpled up tinfoil. There's a few different things, but that's kind of what they had suggested. And mine has a black electrical tape. A buddy of mine, LD Burton, had actually, he's a thermographer and LiDAR pilot out of Texas, and I've seen him using his idea that he used for T-Reflect board for their quantitative analysis, and he actually sent me the model that they have. He made it, so it was pretty cool. But yep, nope. So to get back on point is that when we're out there to give true temperature readings with a drone, right now all the thermal payloads within drones have the atmospheric attenuation files turned off, which means that the settings and parameters for reflected apparent temperature, distance to target, humidity, temperature, they aren't accounted for in current thermal drone payloads, M3T, H20T, M30T, the older ones. So when doing true temperature work, we would have to fly to the altitude that we're going to capture at, take a picture of that T-reflect board, and then in post-processing, enter the information to kind of balance that out and account for that environmental conditions. So the difference between that and the H30T is that now the H30T has the ability to enter in those environmental conditions on it. I haven't had a chance yet to test it versus doing it how we would traditionally collect the data, but that is something that's on our to-do list. So yeah, the H32, it will be our newest thermal payload that we'll be adding. It will do awesome for commercial roofing. What I hope that it'll do is help with TPO. So a lot of roofing systems, going TPO. Well, kind of give a quick little rundown of TPO is that TPO has, generally speaking, an emissivity of 85% with a reflectivity of 85%. And what that means is that the emissivity is that roofing membrane's ability to reflect or to hold their heat, whereas the reflectivity is how good it can reflect. So when that moisture gets into a TPO membrane, the sun that beats down on it to heat all that moisture up is only getting about 15% of that through, because of the emissivity or the reflectivity of the TPO is only letting 15% through. Of that 15%, 85% of that is being released back due to the emissivity of that TPO. So to have 4 times as much thermal resolution as the H30T does, it leads me to believe anyways that moisture would be easier to detect using drone thermal imaging on newer built TPO roofs. So what we like to tell clients a lot, the TPO roof that's been installed within the first year, these are the kind of issues that we could come up with. So we try to be upfront about that, whereas the H30T, we're hoping that will quell that and kind of offset all of that and be able to provide results no matter what time the install had happened.
So you're finding a TPO roof when it's just installed for a year or two, it's very hard to get a thermal
yes, sir.
recording off of.
That being said,
that was one of the questions I was going to be coming up with. What about like coatings, aluminum roof coating and silicone coating?
Is going to be very, very difficult. That being said, something that you could look for is corrosion and things like that, where the moisture could. But the reflectivity for metal roofing is very, very difficult. Again, for those kind of things, if we could get access to the attic space or something of that nature, to get in there with a handheld, we can actually do that reverse and do it in the morning time where we'd be looking for cool spots as the sun came up and was heating up all the dry insulation. And I guess that was kind of a topic that we had in the list of topics to talk about,
Right.
was the thermal capacitance and how that works. And I like to describe that with the thermal capacity of dry insulation versus wet insulation is very similar to like a piece of toast and a Pop-Tart. So historically, we know that when we put our piece of toast in the toaster, when that thing pops up, we got to get our butter on it. Otherwise, that little square of butter is just going to sit there on top. That being said, on the other side of that coin, we know that when our Pop-Tart or toaster strudel pops up, we know not to go biting right into the middle of that thing, because that jelly in there is going to be very, very hot. The
Right.
reason they have different thermal capacities, and the dry insulation is like that toast, where it's going to get heated up during the day by the sunshine, but as soon as the sun goes down, it's going to cool down really quicker. Whereas the wet portions of the roof are more like the toaster strudel and the Pop-Tart, where once they're heated up, the inside and that belly of that is going to stay heated up for a while. And that's what we look for once the sun goes down, which they call they call it a thermal crossover. Is kind of when the temperature has been going down and the dry insulation is cooling down, and the moisture portions, or what would be moisture, would still be starting to show. And these kind of things are fluid when it comes to truly capturing good data with a thermal drone. Sometimes it can take a couple of different captures, just because you show up at, 9 p.m. at night, you might not have accounted for how many times, that roof might be a rebuild. And they later on in the evening, even further, midnight, 1 a.m., now that all that area that could possibly be anomalies has cooled off enough to where you would be just truly seeing the moisture. So there's different things that come into play in that. It's all really kind of case by case, but those are a few foundational things that the viewers can kind of wrap their mind around to get it, understand conceptually what the difference between the dry versus moist insulation or wet insulation, and what we're looking for and how that shows up thermally.
Yeah, and I think the other things that can throw thermologists off is that a lot of times they see these hot spots and stuff, and they don't realize it's a lot. Sometimes it's not from wet insulation or wet roof. Sometimes it's just from coating wearing off, or
Oh,
puddles. That there's a lot of
dirt,
things
build.
they got to look at.
Yeah, no, for sure. There, it's very like another thing I like to do is I get there prior to sunset, because I like to capture a color model of the roof. So when I'm on a project, they have me pretty much that whole. I truly try to wait for a fresh rain and then give it a full day of solar loading and then go in that night. Sometimes obviously in the real world that isn't always possible. And some clients are like, look, man, it was a week ago. We got some rain, just fly it, and yeah. And so in them scenarios, we're just doing the best that we can. But you are very correct. There is more often than not anomalies that are showing up that can be explained, venting that's coming out, so that's even taking it down to understanding, what the difference between wind versus moisture would look like thermally, versus wispy versus kind of puddly looking, things like that. So yeah, no, that's definitely good things.
Yeah, it's like one customer we have. We've been doing work for him for many years, commercial buildings, and he had a company came out and had a thermal drone up on a neighbor's building, and then while he was up, he flew all the other neighbors' buildings, and then sent a letter to all of them with a report.
Yeah.
And he says, "You look where all the light spots are. The roof is totally saturated. So I'd love to come and sit down with you and go over the situation, And so they, since we're their customer, they sent us their report when they know what it means, And the roof has been being patched for many years, so parts of it are just our old coating wearing off. Parts are new white granulated torch down. parts are some coating. So there's everything different on that thing. So saying light colors and dark colors just doesn't cut it.
No,
It
no.
means it's going to be wet.
Yeah, no, we've been
So,
more like brought in. So it's not as if we go out and advertise for that. Like it's more like roofing companies will bring us in to be like, hey man, we're doing a rebuild, or can you give us your opinion? Yep, because no, we don't do cuts, core cuts, anything like that. We truly try to stick to the non-destructive testing portion of, thermography and the advantages of that. So no, can never claim that we have all the knowledge of all the roofing, but when it comes to membranes and playing roof detective for discovering anomalies, we got you. But yeah, as you said, I agree. More often than not, anomalies are explainable by something that we're looking at on the color side of things, or if we get access to the roof and can actually walk it, to go up there and kind of take an inventory, then compare that what we've seen visually to what we're picking up on the thermal model.
Yeah, that's why I like to go out and make sure I get some nice close-ups, daytime photos as well to go along with the night photos. So a lot of times I'll go out there and I'll run the same thermal drone during the daytime, maybe set it up as a mission. Go out and take all the photos I want to take in the daytime, and then go back in the evening, and it's already set up to take the exact same photos that I took during the day. So we have a good comparison between the thermal and the visible light photos. And then any anomalies that show up in those areas, we're able to zoom in and actually see maybe what's going on.
Yeah.
With a nice close-up. So that's just some of the things I've been running across. Okay. Anything else you want to add to that, Bob?
No, that's kind of just the concepts of it all, what we're looking for.
All right, I'll bring up your next photo here.
Again, that's a morning image. Yep, of a roof. And so that's what I was saying. Like when we go in, we can go in the morning to look for cooling spots, but that's something to be careful with because evaporation can come into play as well. But when with new TPO roofs, with some roofs, you just residential roofs a lot of times, because they have a peak. Yep, that's where we'll go in, is try to go in on the inside and look from the attic. Now,
have you had a lot of good scenarios with doing residential roofs, shingle roofs, things like that?
Man, it was more small businesses versus residential per se, like where there would be small businesses that were doing work, say, out of a residential or a peak roof building that we were brought into.
Or maybe both.
Yeah. So it's it by no means are we at individual homes, doing that. I honestly, I just offered my father-in-law, because he's looking at getting a roof replacement up here, and he was telling me some of the things that is going on. So I was like, well, man, let me get up in the attic, with one of my handhelds, and we'll just see if what we can find, and go from there. Yep. So yeah, no, it's more things like that, where it's smaller commercial businesses that just happen to have like a peak roof or something.
Have you done much with doing checking the outside for heat loss and stuff on the outside of buildings?
Oh yeah, yep, definitely, yep, good. We've done to see if insulation is settled. We haven't. In theory, you can look at storm windows that are double paned. If the pane had steel had cracked and the gas had escaped, we can see that with thermal imaging. But that can kind of be difficult to it being because that's one thing you can't see through a window with thermal.
Right.
But yeah, no, definitely insulation settling. Not so much like blower door or blower, measurements to where we're actually taking, but we've done tons of seeing where energy loss is happening, whether that be doors, windows, from just having a great delta T, whether that be the hot summer and asking them to turn down AC, or vice versa, and in the winter asking them, hey man, we're going to come by this evening. Can you turn up the heat to 75? Just kind of create that as big of a delta T as we can. Yep, to make the readings.
Yeah, I had my sister one time was trying to figure out where the stud was in the wall to hang a picture. And I had my truck parked outside. Well, let me go out and get the handheld. Let me see if I can see anything. So I go out there, get the handheld, bring it in. Sure enough, you see every stud in between the
Oh
walls.
yeah, yeah,
You know, every single one. I said, I go a little bit 2 inches to the left and put a little pencil mark. There you go. There's your stud. Hang your picture.
yeah, yeah.
But not always you can see that, but sometimes, and it's not exactly a good sign. Okay, let's see here. Now I got your little, just showing your setup here.
Yeah, this is actually from this is our M350. It's our bigger drone that this is what the H32 will be ran on. That's the camera that's on there is a P1. We do that, use that for high resolution modeling. We recently just wrapped up assisting on a contract for over 250 cemeteries. They were all over too. I flew mainly Wisconsin, Illinois, and Michigan, but there were sites from Minnesota to Florida, the Mississippi River east, all the way to DC. But they wanted 3D models and 2D ortho maps of the cemetery sites. Historically, when someone goes to buy, a plot or something of that nature, they still have a big binder that they have to flip through all the pages and see which ones are available, then compare that to like a drawing of the layout of the land. Whereas
I got you. Yeah,
now they see this digitally, their undeveloped space, they can estimate, how many more plots they could possibly put in there, that type of thing. It would, every place that I was at, they were very happy, very excited. Like they were even talking about like how, say we went to, a relative's funeral way back when. We didn't exactly remember where they were buried at, but happened to be close and wanted to stop. Well, now they have just a little map that they're like, okay, go out to that, they go to this monument and then you're going 15 paces to the right. Whereas now with these models, like they can literally read the name on the tombstone from the 3D models. That's the resolution that we're providing for their models. And so a lot of advantages to that. But that's kind of that. The M350 is the drone, and that is a very versatile piece of machinery. Flies great. And that's one of our main workhorses.
Yeah, what do you find as a thermal drone for doing, like inspections in it that you like to use the most?
It depends. If it's solar, it's hands down the M3T. Yep.
That's why I was going there to ask you about that next.
No, the M3T for solar is phenomenal. It has the ability to take simultaneous thermal and RGB images at 0.7 seconds. Whereas the M30T, the H20T, those are the lowest they can go is 2 seconds per image. So when it comes to flying solar, the M3T a lot of times can get solar sites done twice as fast, sometimes 2.5 times as fast as, the other drones. And I use it a lot on this smaller projects that we have for the roofs. But, I was almost going to go down to Missouri for a 400,000 square foot roof where, I would have definitely had the M350 and the H20T. Honestly, I was going to demo the H30T on that roof. We're able to fly a little bit higher. The H30T has a 19 millimeter lens on that, going along with that more thermal resolution. So you're able to get a little bit faster. That's one thing that I like to be careful on is my flight speed. When we look at things like that, we have to take into consideration, as we had said earlier in the show, our environmental conditions. One of them is wind, and any wind that's 15 mile an hour and above can reduce the amount of energy getting back camera up to 50%. Yeah, so that's another thing that I like to keep in mind when I am doing my thermal inspections, is I don't like to fly any missions faster than 10 miles per hour. You know, a lot of times solar sites might even be at, well, no, it's set. That one's a little bit quicker, but yeah, nope. So
These solar sites now, they usually have their own software program that you fly using their program, or do
yeah,
you do that
that
all in your own?
that's kind of all size dependent and the client. For instance, I'm going to fly a 189 megawatt site, which is, I don't know, it's about 1,000 acres total, next week down in Union City, Michigan. It's this one of the state of Michigan's energy companies, DTE. They're putting in like 14 different sites, and we got so far we're flying 2 of them. The first 2 that are coming online for this year, we'll be flying them, and hopefully we'll be flying the ones that are coming after that as well. But that one is a very cool project. Yep, that's so for the bigger corporate clients like that, 9 times out of 10 they want AI software reporting. The biggest company right now is Raptor Maps, but they don't really do processing for smaller companies. Like, you have to have a pretty large portfolio to approach Raptor for their AI software. So that being said, there's a few other companies that do.
I think one called Clearview or something.
I've never messed with them, but SimpleMap.io is one company based out of Chile. Very cool people. That's who we're working with on this project for Michigan's that Michigan site next week. Another is Above Surveying. They're out of Canada, I believe, but they produce AI reporting too, just at a more downscaled level, whereas these guys are trying to be Raptors competition, you know, or just get a share of the market type of deal. Yeah, so because like I've reached out to Raptor, and yeah, no, you just have to have a pretty significant portfolio, you know, for them to be like, okay, yeah.
Yeah, I'm just curious. I just got somebody requested me maybe do a solar, which I haven't done before, you know, and I think they were using Clearview. It's all set up already through their network. I just wasn't sure how that works, you know.
Yeah, no, so for something like that, they'll probably literally just provide you with all the flight parameters. Like, here, this is what the altitude of the GSD we want you to capture at. They're going to tell you which way to fly. It's pretty simple once you get into the flight planning, especially with the M3D. Yeah, they have in the advanced setting area, you can enable custom camera, and that allows you to orient which way you want your drone to fly. So a lot of times with solar, you're going to want to have it. A lot of clients like Raptor prefer to have the drone facing, say, north the entire flight. So it's going to truck down, back up, like that all the way through it. So there's a way in the advanced settings to be able to enable custom flight path, and it'll show you a little arrow which way your drone's going to face. Then you can set your gimbal angle at whatever parameters they give you, and then yeah, from that part, it's just really just you're building your flight plan, setting your parameters, and then showing up on site and getting. You would probably need an irradiance meter to check how much sunlight is coming down. A lot of the software companies require a minimum of 600 watts per meter squared of solar irradiance during a solar drone inspection or thermal drone inspection. That's kind of the standard.
What do you do? Take a picture of that? Or
yeah, yep. It's little like handheld device points up at the sky the same way that the panels are facing. Yep, and you just match that up and then take a picture of it. I take a picture with my cell phone and then have the location services turned on my images, and then I capture or caption that image with what site that I'm at, and that location tag is in there. And that way, when I submit that to my point of contact, they're able, if they want to verify, to look at that image, see where the meta information, and to verify that I'm actually on the site versus, being somewhere else.
Right.
Pictures.
Another question I have for you is, how's it reading a roof that has gravel on it? You got a couple of different kinds of gravel. You got that big river rock and then pea gravel.
It can be difficult. That would be a roof that I would definitely get up there during the daytime, and get some really good imagery via drone, or if I can get, I always try to get access to it just to see. Obviously, as long as it's a working building, if it's, one of the,
right, yeah. You don't want to fall through.
To do the best that I can. But yeah, no, gravel is a difficult one. That definitely is a difficult one. That I have to say that I do, lean on a lot of the visual imagery that I can collect to compare for that. Because gravel can.
I've heard like ballast is about impossible.
Man, because it can be just like debris. It can show, and some of it can even kind of reflect. And
I've heard that someone said somewhere once that to go out there ahead of time, have a crew go out and clean all the seams back a couple feet, let them sit for a few days, and then after rain, go back and do a thermal shoot of all the seams. It'd be a lot of work, moving gravel off and then back on.
Yeah, they would have to be paying me a nice little amount to have me up there shoveling off all the gravel.
Well, I don't mean you necessarily shovel it, but they could have someone shovel this.
Yeah,
they'll shovel the seams ahead of time, then you just go shoot it. But just wonder if you ever heard of that before.
Yeah, that would be cool though.
Yeah, so. All right, then that's that one. Where are we at here? And now I just have a few pictures that I just added in here just to see, get your kick and thoughts on any of these. These are just some different things that I've shot. And here's one here. This is a visible and a thermal. This is a building we actually just ended up roofing afterwards. But what we did is, like I said before, we went out here and during the day, went out here a couple of times, flew a couple of different missions looking to see, just check what obstacles we might have to worry about as far as the trees and wires and towers and what have you. Got some different, did a mapping mission on the roof in the daytime, and then followed up and did a mapping mission on the same mapping mission in the evening with the thermal drone, with the same thermal drone. And then these are what we was able to pick up, and then decided where anomalies were from these two different flights, and went out and did, by separate contract, gave an offer to go out and do core cuts to confirm these anomalies, and found out there was only 2 wet areas on the whole roof. So it turned out pretty well. So two areas that we had to cut out.
It can be challenging with the kind of ventilation system that's on top of this roof. That can, because a lot of that is more than likely air and radiated heat from, coming from them fixtures versus actual anomalies.
A lot of those, all the yellow, those are all HVAC units.
Yep.
And then there's a few areas like over, say it's red over here, but this red actually is a new modified patch. Some areas are just the granules coating worn off. So there's different things. So a lot of them where you think, okay, just like I said, this other guy sent a report saying, hey, everything's wet up there. Not necessarily the case. That's why a lot of times we need a good thermologist like Robert here. And then they'll suggest that you have a good roofer follow up and check these areas and see if they are indeed a problem.
Yep. No,
so that's what we find out with these. And that's that one. This is just another one, a building similar to it. This here just shows you how you see nice red here, like it would be real, like they want to say right away something going on here. That's just a white grain, or actually this is a real weird one, Bob. is right here in the center. This white, you would think looking at it before we got up there, this is white granulated. This turns out someone doped the edges in on a piece of TPO. This is actually a piece of TPO that they just
like a weird Band-Aid patch.
Yeah. So they put some up, put this TPO down, and then just doped in the edges, doped the membrane and the edges on a granulated modified roof. And this is the low area, the drains are in this area. That's on all three wings here.
I see that.
So
that's wild.
Yeah. So that's why I brought this picture up. I thought it was kind of interesting, something I thought you like they get a kick out of it. And then like all these other, this whole roof is coated. Pretty much. So you see all these other yellow areas. A lot of this is just where the coating's worn off, so it's heated up. These pictures I took also were like mid-morning.
Yeah.
So you're not going to get the best results anyhow. But I was meeting an engineer there that had us cutting core samples, and he's setting up for an insurance job to redo the whole thing. So he's an engineer we've worked with in the past. So he had us send a service crew out to cut cores all over this roof. So I figured, well, and I had to go out there and meet him. And anyhow, so I figured, well, I'll throw the thermal drone up. Now, this guy is engineer, is also a drone guy, but he just uses an old Phantom 4 Pro.
Yeah.
So, but that's what this is. It's almost exactly the same building as the last ones. And then here's just from the same things, it's just another shot of it. They were kind of interesting.
To have them color images, that's I am always there before sunset. I need to have color imagery, because that is especially that kind of roof. Jeez.
Yeah. So I went up here first, looked around the roof, and then I went and put the drone up as well. And then the other thing that could really throw things off here is these three wings on the outside here are all plywood roofs. The center core right here is concrete.
Like, I wouldn't have known that was a TPO strip down the middle. I would have been like, man, that's really weird. What? Yeah, that's.
So I thought it was a very interesting picture, so I thought I'll put that one in here.
Yeah, that's cool.
And then the other thing I got here is this is just a report that I made up myself. But it just shows, gives people an idea of what they can maybe expect in one of your reports or our reports or anyone's reports, and what they should expect if they get a report. So this is just like, I took all the names off, addresses, everything, just so we don't need to broadcast our business all over the internet. But here it just shows, like in my report here, I put a nice, these are mapping missions we put on here. So there's a visible, there's a thermal of the same building, the same shots. Just a little bit of stuff you'll find in there. They have a little introduction, some different information. But, so if you get a report from somebody, they should be giving you quite a bit of information. Like I know Bob's reports are pretty much the same as ours, just maybe a little bit different. But just gives you an idea of what to be looking for when you get a report. And then like most people don't do this core. If you have someone do cores, you need to make sure that they're a roofing company that's capable of properly repairing them. You'll get a lot of fly-by-nights or just hokey people. You see how the wet insulation is here. But you get a lot of people cut the hole out here, and then they might just stick the core back in the hole and throw some dope and mini or something over it. So, which is okay if you're definitely going to roof it real soon. But if you're going to have cores cut in your roof, you want to make sure that it's properly, sealed back in, tied into the roof system properly, so that because otherwise, in a few months, that core can start leaking. And then you thought you had problems before, you just got another whole new can of worms. So what we did after we took the thermal shots of the building, you can see the whole building. We marked them from what we got with the thermal. We marked the areas that we thought needed to be checked. And then we suggested core cuts in those areas. Now, like Bob said before, there's other ways. You don't have to cut the roof. They have different meters that they can check for moisture through the roof, non-destructive ways. So there's many ways to check for moisture I didn't have access to one of these meters, but a lot of the guys have the meters and they'll come and run a meter over it. And then they find, okay, the meter says there's 30% or 60% moisture under this area. Then they might want to do cores in those particular areas instead of all over and find dry insulation. That's one thing I would think Robert probably looking at. Is that correct, Bob?
Yeah. I mean, that's just what we try to help with, but to be honest, the way to truly know is by doing core sample type. Yeah.
Mm-hmm. So this is just basically what the report will look like, and then they'll, tell you about it, a little bit about what you're looking for. There's some different things will be in there, but visual versus thermal, and then what equipment they might have been using on the roof as far as for cameras and what have you. A little diagram. So these are just some of the things. Reports can be different. This is just a report I made up myself, and I know Bob made his as well. So you just want to make sure if you have someone come out and do a thermal report for you, that anyone reputable is going to give you some kind of report.
Yes, definitely.
And check their references and make sure they know what the reports mean. Make sure they've been, they've done enough to know what they're going to be looking at. Just because some guy went out and bought a drone, has a thermal camera on it, doesn't mean he's going to be able to tell you what it all means.
Very true.
Okay. That's where we're at there. Now, let me just look here. We had a few questions where we're kind of go over here. Bob, can you explain how long wave infrared detection differs from other forms of thermal imaging and why it is so effective for roof inspections?
Well, without getting too technical, the long wave range that we're using within thermal drones, geez, I don't even really how to explain that. So there's different spectrums, levels of different levels to the spectrum when it comes to radio, visual, thermal. The range that we're mainly looking at with our drones is built for like water and moisture type sensing, I guess, to put it. Like we have gas optical imagers, so it's just reading at a different spectrum than our long wave camera is, so when they're doing oil field pipeline inspections, looking for, different gases that might be leaking, coming out, it's just a different spectrum versus the long wave, which is, folks, man, I'm not explaining it truly right. But yeah, it's just different levels of the spectrum that we're looking at versus other thermal imaging.
The other thing I wanted to bring up is what do you think? We were talking before, I meant to bring it up before, but what's a good height over a roof to be doing a thermal or visible to get accurate information?
That really comes down to like how many your measurement field of view, how many pixels are you're getting on, say a square inch. Okay, so a lot of the inspections are with like the M3T. The M3T has a 9.1 millimeter thermal camera, whereas I said the H30T has a 19 millimeter. I believe the H30T has a 13 millimeter. But what all that translates to is that I'm usually flying at around anywhere from 75 to 90 feet above a roof when I'm using the M3T. When I'm with the H20T, I'm somewhere around like maybe 100 to 120. With the H30T, I was at 150. And I probably will adjust that even and going back in at like 125, 150. So I guess it would just depend on what thermal imaging camera you're using, then go from there. There are charts and stuff that FLIR provided us, or the Infrared Training Center provided us, that in our workbooks that I'll refer to. Like when I got this H30T, they didn't even have any written for that high thermal resolution for drones. So it's just, but yeah, I would say if you're using the M30T, I would definitely be somewhere around 75, 90 feet, something like that, just to get a really good.
I use the 3T, but and then can you be too close?
I mean, man, that's what I mean. A lot of the times, like I fly these automated missions, but then I go back in and fly them manually. Now, say we flew the mission at 125 feet. When I go back in to fly manually, I'll have my drone at 125 feet and then start taking images as I'm going down, getting down to like 90 feet, 75 feet. And so then that way our software imagery has the ability to take them images from the higher flight. And then as I stepped it down, link it all together. To where like manually, yeah. I wouldn't say you could be too close other than, the fuzziness within your camera, focusing.
Right.
Another thing is your FFC, your flat field correction. That's what adjusts your thermal camera for drift. And like as the drone is going along. So like say when I'm flying automated missions, at each time I finish a leg of the mission, I'll hit a FCC and it'll calibrate and then go down. And at the end
of each mission.
Yep, I'll FCC pretty much at every leg of the mission, that we're doing. And then if I'm flying manually, I'm focusing and FCCing pretty much just about every image. Once you hover and get above where you want to capture that image at, then I'll FCC, and you'll see the camera kind of reset, and that's just it's taking another adjustment for the drift. So just little things like that can help you just capture a little bit better data. Just trying to. We just try. That's kind of the workflow that we use with it.
What software do you find you use for the thermal images for getting your data?
Well, my partner processes all the models, and he is using reality capture and then using Mira to host our models. But when it comes to like me doing reports and whatnot, I'm more often than not using Thermal Studio and then exporting without image overlays into my own report. I don't like the report that Thermal Studio produces, so I just kind of.
Yeah, that's why I made my own too.
Yeah.
Okay, so the next question here. What are the most common thermal anomalies you encounter in roofing, and how do they typically impact the structure?
Shoot, the most common anomalies are explainable stuff like debris, like what you were saying, buildup getting, for whatever, off to one side, venting, a vent cover being off, and then all of a sudden that's a bunch of extra hot air getting pushed out to one side. Things like that. Yep. A lot of times it's, like air underneath membrane, where on a new install to where I've went back because I had recommended maybe letting some thermal cycling happen, to let that membrane kind of stretch out, retract a little bit. And so a lot of unique little things like that, just come along with
like under mechanically fastened TPOs, you see a pretty good trend with seeing moisture underneath the membrane, frost.
Yeah.
We've seen that quite a bit as well. Okay, we'll go to number 3 here. Could you walk us through a real-world example where thermal imaging identified a crucial issue that would have been missed otherwise?
I could just go back to the when I was talking about that roof with the thermal cycling. That was actually a new a new roof install on an existing building, and I wasn't sure why, but the owner had brought us back out, and he had said he was still seeing leaks coming. Well, he had thought it was coming in from the I think it would be eastern portion of the building, which is essentially the back of the cinema. That's where they were getting leaks at behind the screens and whatnot. And but they hadn't. It was something with the flashing that was maybe 40 yards north of that easterly area of where the moisture was at, and we was actually able to detect two different spots of the moisture. For whatever reason, it just ran in a straight line about 10 yards down the roof. So yeah, we were able to show them with the images and the model that the moisture was actually puddling from part of the flashings and then traveling under the membrane down to that southern area and leaking. But yeah, that's probably my most recent one. That was
we've seen we had similar instances with that. Is that we've seen, let's say, especially with a mechanical system, is we've gone to, if we're doing a mechanical, we'll fully adhere to walls, even though we're doing mechanical. For the simple fact, they say you don't need to, but what we found that happens with just a mechanical flashing wall is that you get a lot of condensation on the walls from all the air gap behind from the maybe cold air or hot air inside and the opposite outside. And a lot of leaks that we've seen have turned out over, especially an amount of time, is that a lot of it's causing from condensation and running down the wall and seeming like there's a leak going on. And a lot of times they can get a hint from that just by the fact, is it only leaking when it's raining, or is it leaking all the time, or when there's a big change in temperature or something like that? It's different things to look for.
Yeah.
So that's a lot of the same thing we found there. What role does thermal capacitance, particularly of water, play in accurately identifying roofing problems, and how do you account for the environmental factors like weather?
We kind of went over that. That was kind of the example that I had given with the toast and the Pop-Tart. The dry insulation would definitely cool down quicker from being heated up throughout the day sunshine, whereas the water.
I remember you saying that now.
Yeah.
All right, we'll move on to the next one. Here's 6. How has the technology behind infrared cameras and drones evolved over the past few years, and what advancements do you expect to see in the near future? I think you kind of went over that a little bit too already.
Yeah, we were going to say, man, if the H30T truly, checks out like that, that really will be a cool thermal payload, for doing quantitative work. So I imagine it'll be more for like electrical overhead power, things like that, where the temperature difference, that delta T, really is playing into the analysis portion. Whereas with us, roofing, it's more a qualitative, to where we're looking for the visual anomaly versus the actual temperature.
Right.
Yeah. So no, the H30T is a really cool camera to come out. I'm like I said, the cameras are just starting to clear customs. The dealer that I'm working with hasn't had their batch in yet, so I may be demoing the H30T again this next week. We just got some fresh rain here, and I wanted to do a new model under some different parameters and just do a new capture and make sure it's.
Well, hopefully the U.S. doesn't mess up your imports.
No, it was. I'm not sure how it all played out, but my understanding that it was on China's end, that they were stopping these from leaving the country because of their. I don't know. This is just stuff that I had read.
No, that's a big mess, is all I know.
Yeah.
Okay. How do you ensure that data collected during an inspection is reliable, and how do you interpret subtle variations in temperature?
Again, a lot of it is comparing with the visual and what we can, the information that we're getting from the client. I like to ask what the membrane is, maybe what the roofing deck is. A lot of times they don't know,
Right,
but it's just trying to get as much information as possible. The insulation, and then it really comes into like comparing the visual versus the thermal. and then we take it a step further and make sure that we're capturing our data properly, whether that be the visual and or the thermal as well. So yeah, no, it is a step-by-step process in making sure that we're trying to capture the best possible, most accurate data that we can.
Yeah, and I really like it too. Like the thermal 3T that it takes, like you said, both pictures at the same time. So,
Yeah.
Getting the visible and the thermal, so you get the exact same spot, exact same. It's a really makes it a whole lot easier figuring out what you're looking at. Really can
Yeah.
be handy.
Nope, definitely.
In your experience, how effective are drone-based thermal inspections compared to the traditional ones?
I mean, everything has, its limitations. Like we've talked about a few of them. With gravel type roofs, with new TPO roofs. So I think that a lot of times it's going to come down to the person operating the drone or the camera, that person's experience with what's happening. It's his background knowledge that comes into play when it comes to unique type projects. It's yeah.
Do you find with the TPO roasts that, like, say, 5-10 years down the road, it's easier to start tracking leaks on those, or they always give you a hard time?
No, it's usually just that first year. Yeah, it's really and like I said, I really want to get some data with this H30T. It'll just be really interesting to see, how it performs. Because this next round, I'm gonna do some data collection on the same. I'm gonna do a casino over here, and I'm gonna fly the H30T and the H20T in the exact same missions. Might have to do them on back-to-back days, but excuse me. I truly want to compare that to see just the side-by-side comparison of some data that I capture.
Okay. For the best one, the last one. What industries beyond roofing can benefit from long-wave infrared detection and anomaly recognition?
Oh man, solar's a huge one. There I mean, man, there's a lot of different things that, there is health screenings that's being done with thermal imaging, to see circulation issues within the body, for diabetic patients, certain extremities may not be reading as much heat as the other ones because they're getting poor circulation there. Then we can take it into, geez, motors, belts, things of that nature, getting temperature readings off of there, looking at motor cores, seeing how those are tankers, seeing tanker levels with the right conditions. There's all kinds of different uses for it, and I believe that those will continue to take hold. Electrical, the rules, the NFPA 70B, recently, I think it was February of this year, now requires that a certified thermographer be part of their preventative maintenance program. Yep. So it goes on a lot of different things. Yep.
Now, I've found I've used my handheld force, comes in very handy a few times, is frozen pipes.
Yeah.
You can find exactly where it's frozen at, and it makes it very easy so you know where to slowly heat it up so you don't burst it. But it's been very handy in the past, or even a clogged kitchen drain or whatever. You can pour some hot water down this drain and then go look underneath the sink with your camera and follow the hot water and see exactly where it stops at and figure out where your clog is.
Yeah.
So there's a number of things they can do with them.
They're
also good. Handhelds are good for looking for lost pets, like cats. A lot of cats will hide under cars, under bushes, things like that.
Oh yeah.
I do a little bit of lost pet rescue. So a lot of times it's taking handheld. If you got a lost cat in the neighborhood, usually they're not too far away from the original home.
There's literally a lost pet and rescue group on Facebook that is a network of thermal drone pilots throughout the country.
I'm in a couple of them.
Yeah, okay. Yeah.
So yeah. So yeah, it's been very interesting interview. I really appreciate all your insight and information. And let me tell you, I've looked around YouTube, looked all over trying to find anybody that had any kind of knowledge or anything to add to anything, and you're really the first I've ran across that had anything worth putting in or putting out there. So I really appreciate your
Guys having
help
me on.
and you on, and hope to be doing some more with you in the near future. And all of our shows, you're always welcome to drop in if you'd like. All you got to do is pop in and say, drop in the comments. Say, Chuck, Robert out here, drop me a link, and I can send a link right to you and invite you right in on any show that's going on. So you're always welcome back. If you think of anything you think would be a good topic, you can bring that along as well. So anything else before closing, Robert?
No, I just appreciate the opportunity. Yeah, it was a very good conversation today. Yeah, definitely.
Yeah, I really loved it. I really loved it. I learned a lot, and really enjoyed talking with you today.
Yep, man. Thank you guys for having me on.
Yep, we'll be talking to you, and you have a great rest of your day.
You as well. See ya.
Bye, everybody. We'll talk to you next Thursday, 1 p.m. Have a good day.